All right, first of all, we're going to be solving quadratic functions by factoring. And we want to understand what a zero of a function is. First thing is our definition of a zero. It's an x-intercept. It's a location on the x-axis where the y value has to be 0. Okay, because every point on the x-axis has a y value of 0. Now, hold on. In our first example, I have found a mistake. Okay, so this sign right here should be a minus, not a plus. The reason I know it's a mistake is because it doesn't match the picture. So how do the zeros of the function relate to the factors of the expression? So let me just change that. So if we factor this, we know that we're going to have a plus and a minus. And our factors of 8 are 1 and 8 or 2 and 4. Now it's going to be a 2 and a 4 combo. The 4 has to go with the negative and the 2 has to go with the positive. Now, how does that relate to the picture? Well, you take the factors and you set them equal to 0 and you solve them. So the first one solves to negative 2 and the second one solves to positive 4. Well, here they are. Positive 4, negative 2. So, when we factor it, we can easily see the x-intercepts. Now, this also helps us with other things. For instance, what's halfway in the middle? Well, a couple things. Remember your axis of symmetry, right? We know that starts out with x equals because it's a vertical line. Well, what's halfway between negative 2 and positive 4? Well, literally, you could average them together, right? And get the number 1. But that's not the only thing you just figured out. You also figured out the x-coordinate of the vertex. And then, on top of that, you could find the y value of the coordinate by plugging it in. Just like we did in class the other day. So, 1 minus 2 minus 8, that ends up being negative 9, which matches the picture. Now, the reason I say that is, and the reason I bring up all that extra stuff that wasn't asked for, is because if you were given an SAT question or an ACT question and they just gave you this parabola and you don't have a graphing calculator or Desmos to use for it, then you need a way to figure out what are the x-intercepts? What's the vertex? How do I know if this, all of that stuff. So that kind of helps you with some of that. It says, now, if you look down below, you see for the graph above, why in the world is this not? Come on. There we go. How in the world are we, where is it positive, I should say? Where is it positive? That's what it's asking. That's interval notation. Don't forget interval notation. Well, obviously, the only part of this graph that is increasing would be this side of the graph. So, knowing that, we start at 1 and we go to infinity, right? 1's in the middle, infinity's out to the right. Remember, these are x values, not y values, x values. Keep that in mind. Okay, so let's go over to this other one and see if it matches. All right, so we're going to factor this thing. We got our x's. We know that both signs have to be the same and both signs have to be negatives. Factors of 20, we got 1 and 20, we got 2 and 10, we got 4 and 5, and that's all our options. And of course it is going to be the 4 and 5 option. Now, when does this thing equal 0? Only if this equals 0 or if this equals 0. Now, the importance of what we're showing you will be shown below here in a minute. So x equals 4. Whoa, that's a bad looking 4. Which that matches. X equals 5. That matches, right? And where is the graph negative? Ooh, different question. Now we're talking negative. That means below the x-axis. Well, that would be below negative. That's parenthesis 4, comma 5. Now, why not brackets? Because at 4 and 5, it is not negative, it is 0. So, no brackets. Brackets would cause you to lose points on this question. So, don't be that. Now, here comes something called the zero product property, which we've already kind of looked at here, but we're going to maybe state it more formally. The zero product property states that if a product, that means multiplication, of real number factors is 0, then at least one of the factors must be 0. Okay? So if you had two things that multiply together to give you 0, then what do you know? You know that either A equals 0 or B equals 0. Well, that's what I just did up here. You know, in the first example, I said, well, you either have to have x plus 2 equaling 0, or you have to have x minus 4 equaling 0, or in the next one I had x minus 4 and x minus 5 equaling 0. You have to have one of those, otherwise there's no way to get 0. Anyway, so that is the more formal set of notes, or it's called the zero product property. Okay, next slide. So once again, x minus 5 equals 0, x plus 3 equals 0. And so my two answers are 5 and negative 3. Okay, so when it's simple like that, most kids get that really quickly. But then sometimes kids fall apart when we get to stuff like this because they simply don't want to do the solving to get a fraction. Well, they expect that it's just going to be a piece of cake. Maybe I should back up and write that a little bit smaller since I took all my space. 3x minus 2 equals 0. 3x equals 2. Divide by 3, and x equals 2/3. I mean, literally, kids are like, well, that's too much work. I can't do that. 2x plus 5, 2x equals negative 5. Divide by 2, x equals negative 5 over 2. Now, this is one I always worry about. You get it in factored form, and kids don't know what to do with that first one. Now, kids always know what to do with the second one. They're like, x equals negative 1, and then they make up all kinds of crap for this other one. Remember, all you're doing is solving for x, so how do you get rid of multiplication? You divide. And what is 0 divided by 4? 0. So one of the actual answers to part C there is 0 itself. I'm always worried that kids will not know what to do with that, and then they usually just say 1 or 4 or something weird, and you're like, wait a sec, you didn't set it equal to 0 and solve like we are supposed to. So, before solving a quadratic equation by factoring, make sure to set it equal to 0, okay? Obviously, in the next example, B and C are already set equal to 0, but the first one ain't, so first thing I do is bring that over. X squared plus 7x minus 18 equals 0, right? You can't use this zero product property if you don't have it ready for that. And then, yes, we're going to factor it. And we're going to have a plus and a minus, because that's the only way you can do that. And then your factors of 18, well, we got 1 and 18, 2 and 9, 3 and 6. Let's see here, what works? I think it's going to be the 2-9 combination, right? 9 for the positive, 2 for the negative. And so now I can set the factors equal to 0 and solve them. And so my answers are -9 and +2. Those are the two places where it crosses. Remember, these are x-intercepts for the parabola. If you're trying to look at a graph, they're x-intercepts. If you are just solving an equation, these are your solutions. So, kind of has a two-sided effect there. Now, remember I talked about factoring, how you pull out a greatest common factor? Well, the greatest common factor here is x, right? So, you're literally going through, just like we did before, and dividing each one by the GCF, so you know what goes in the parentheses. And you set the two factors equal to 0, so this factor and then this factor. Well, isn't this one already solved for? I don't have to do anything to that. And the other one's pretty easy also. So those are my two answers, 0 and 5. Alright, look for GCF on the next one. Looks like 3x is the GCF. So 3x goes on the outside. That'll leave me x plus 7 equals 0. Set the two factors equal to 0 and solve. Right? Divide by 3. X equals 0. And x equals -7. Alright, pretty straightforward. Nothing too terribly complicated about that one. Do we have anything else on this slide? We do not. Next slide. Solve each of the following quadratic equations by factoring. Okay. Alright. So, let's see here. If I factor this, oh, does this have the same, that pattern where we take half of it, take half of the middle value and square it, and we get the end value? Oh, that means that this is a perfect square. So when I do my factoring, I'm going to have x minus x minus. Ooh, that's a bad looking minus. And what factors of 16 do we have here? We got 1 and 16. We got 2 and 8. We got 4 and 4. And it's going to be 4 and 4. That's the only thing that adds up to -8 in there in the middle. And so that's x minus 4 squared equals 0. Now, what's going on with this one? Well, it's a little bit different, right? It only has one x-intercept. X equals, right? If we set the factor equal to 0 and there's only one of them, then we only get one x-intercept. And you're probably saying, well, how in the world? Well, here's the situation. All right? Katy Perry, she sung about it in a song. I kissed the x-axis and I liked it. That is exactly what's going on here. You got to listen to the words of the song. The a value here is a 1, so we can use our pattern 1, 3, 5, 1a, 3a, 5a, over 1, up 1, over 1, up 3. 5 won't even make it on the graph, so we can duplicate these points to the other side and draw our picture. But the idea here is that the parabola bounces off the axis. It doesn't cut through the axis and then go back up. Okay. Question E. First, always start with a GCF. Remember, you're just going to go through, everything's got a 3 in it, take out the 3. Lower this down. 3. We got an x squared minus 8x and a minus 9 equals 0. And when we do this, we get 3x minus x plus. Now, there's only a couple things to do. We got a 1 and a 9, or we got a 3 and a 3. I think this is going to be the 1-9 combo. 9 has to go with the negative, 1 has to go with the positive, so it adds up to a -8. Now, I get a lot of students who make mistakes with this one right over here. This is a constant. It does not change. You don't get any information from that. The only things that will give me answers to this question are the other factors that have x's in them. that 3 sitting out there in front doesn't do anything for changing my answers. So x equals 9 and then x equals -1. Those are the two places where it crosses the x-axis. But it will, that 3 sitting out in front, will not change my final answer. And no, I didn't need the Berry method because we took the GCF out first. Now, these do use the Berry method, right? Because there's no GCF. So, I'm going to go through my process here of taking the 3, multiplying by the 20, x squared minus 11x minus 60. And then I factor this normally. Let's see here. I think it's going to be minus 15 and a plus 4. Remember, you write down all your factors. 1, 60, 2, 30, 3, 20, 4, 15, 5, 12, 6, 10. Man, there's a lot of things go into 60. All right, so it is 15 and 4. That's the one that's going to give you the minus 11 in the middle. And then, of course, the 3 magically comes back in front of both of the x's. And then we look for GCF. Nothing there. There's a 3 there. And so my correct factorization was x minus 5 and 3x plus 4. Okay, that is equivalent to my original. Then I can set the factors equal to 0 and solve them. And of course I get x equals 5. And then on the other one, 3x equals -4. X equals -4 over 3. Okay? So, needed the Berry method for that one. Okay, one more here. Let's see. No GCF. So, we'll do our trick here. X squared plus x minus 56 equals 0. X plus 8x minus 7, right? 7 and 8, right? If I do 1 and 56, 2 and 28, 4 and 14, and then 7 and 8. Okay. And see, the 2 that magically disappeared at the beginning comes back. 2x minus 7. And then we look for the GCFs, nothing there. I can pull a 2 out of there. So my correct factorization was x plus 4 and 2x minus 7. And then we can set the factors. X plus 4 equals 0. 2x minus 7 equals 0. And we can solve, obviously, -4 is one of the answers. 2x equals 7 produces, and then when we divide by 2, we get x equals 7 over 2. Which is 3.5 if you're a decimal fan. Okay? But I think that's all, but let's check and see if we got any more slides. Okay, so now we're taking zeros, right? Given zeros. And now we're changing them back into factors. Okay? So suppose I start with zeros. And I'm asking you for factors. Okay? So if the 0 is 6, what factor does that go with? Well, I want you to keep in mind that every factor in the universe, all of them look like this. X minus a number. And I know what you're going to say. Mr. Stailey, that's not true. The next one starts out with -7. It doesn't look like, oh, but doesn't it look like x minus -7? What happens when you do the double negative? Oh, that's what he means. That's why it turns into plus. That's right. So now I have my factors. Write the equation of a quadratic function. So we got x minus 6, x plus 7, and they wanted it to be a quadratic function, so equals 0. We'll just put equals 0 at the end. Okay. They never said that I had to change anything to standard form, so I'm going to leave it as is. If they ever wanted me to change it to standard form, then I'd have to multiply it together, but I don't think so. Now, I do understand that we could write this x minus 0, but what is x minus 0? Isn't that just x? So we're going to change that to just x. What are we going to change the 9 to? X minus 9. They want it as an equation, so I'll put equals 0 to make them happy. Now, technically, to be quadratic function, it would be equals y. Writing a quadratic equation with given zeros. See, they're confusing two things here, but we're just going to go with equals 0. Okay? Not to be confusing. Sorry about that. Just math teacher brain going crazy. Now, the first one's going to be easy. X minus 4. Okay? That one I'm not too concerned about. Now, what's the slow motion version of that? What's really going on? When x is equal to 4, really what you're doing is you're pushing that to the other side, and so you get equals x minus 4. That's where that x minus 4 is coming from. Now, the reason I'm showing you the slow motion version is, what do I do when it's a fraction like this, negative 3 over 2? And so, and I think I drew the arrow the wrong way on the last example. Oh my goodness, what's wrong with me? It wouldn't be going that direction. Hold on. It would be going the other direction, right? That's how you get the x minus 4. Duh. I wish I was paying my attention. I'm trying to rush too much. So we want to move that to the other side, but I got a trick to show you. We're going to multiply everything by 2, which will give me 2x equals negative 3, and then we're going to move that to the other side. So the factor that we want is 2x plus 3, right? 2x plus 3 is equal to 0. And then we'll put our equals 0 in the end. So instead of writing x plus 3 halves, x plus, I know a lot of people would say x plus 3 halves. But I would rather see you not have fractions involved in your factors. So this has no fractions involved, no fractions with denominators other than a 1. So same thing here. Starting out with x equals 2/5. So multiply by 5 on both sides. So that's 5x equals 2. Bring the 2 over. So 5x minus 2, which is obviously the more difficult one. And then the 1 over here, x minus 1, that's a pretty easy one, equals 0. So here are my equations. I guess I should have circled them just so that, it was very obvious what my answer was on those. But those are those 4 answers. Then down here, the last part says write part C in factored form. Whoops. Write part C in factored form. So let's take that and multiply it together. And so all we're doing, pick your favorite strategy of how you like to FOIL things together. If you like to use a box, or if you just like to, put, them one over the top of the other one and start multiplying them together, it really doesn't matter to me. If you like the box strategy, then you would be filling this in, and if you like the other one and you're going negative 12 and 8x and 3x and then 2x squared, if this is your strategy, we're all going to come up with the same answer, right? 2x squared plus 11x minus 12 equals 0. This is the standard form version of part C. But like I said, I don't care whether you use a box. Wait a sec, did I make a mistake? I did make a mistake. That's a minus 8x. I saw that mistake. I need to fix it. Where is my erase tool? Because it's not positive 11. It is negative 5. Whew! Good thing I caught that mistake. Okay? Or if you just like drawing arrows, like some people will literally just take the 2x plus 3 and the x minus 4, and they like to draw these two arrows, figure out that, draw these two arrows, figure out that, and add like terms. That's a good strategy too. It's all up to you what you want. And I do believe that concludes our notes for this lesson. See you next time.